an interesting subject. Now, edge angle is the other side to blade geometry. So you can have a thin blade with a very staunch or very steep, obtuse cutting edge. So just because you ground the knife thin doesn't mean it's going to be sharp. The sharpness comes from edge angle. You can have a very thick knife with a very shallow edge angle, and it's going to cut like hell. But at the same time, a very thin edge is more delicate. So the edge angle is a variable that you've got to, as the user, take into account as to how do you want this knife to perform. And there's no correct angle. For example, on the Lansky sharpeners, you've got the different angle options, going from, is it 12, 15, 20, 30?
17.
7, yeah. You know, so as the angle becomes steeper and steeper, the knife becomes more and more durable, the edge angle becomes more robust, but at the same time it becomes, let's say, for the lack of a better word, blunter. The steeper the angle is, the knife is less like a razor, but it keeps its blunt angle longer. Blunt, you know, it keeps, how can one explain that better? You know, the steeper the edge angle is, it will stay that way longer. It's a much more hard-wearing blade form than if you'd made it very fine and thin. Flattening that angle out that it becomes very shallow edge angle makes that knife scary sharp, but it's a more delicate edge that has to be touched up more often. So now you, as the guy who's maintaining your knife, will need to decide. You can sharpen your knife in such a way that you sharpen it only once before the hunting season, and it stays that way all season long. Or you say to yourself, you don't mind touching your knife up regularly, but you'd prefer it to be like a razor. You're going to sharpen your knife more regularly, but your angle's going to be shallower. So which angle is correct? Because that's the question one gets asked most often. What's the correct angle to sharpen a knife at? And there is no correct angle. How do you want your knife to perform? And how regular do you want to touch your knife up? All right, now let's talk about things that influence knives going blunt in the first place. Now, certainly when you are cutting very abrasive materials, so let's say you are whittling on a piece of wood that's been lying in the riverbed for a while, you're carving yourself a tent peg or something, and it's impregnated with mud and stones and stuff. You know, that's going to be very tough on the knife edge, that especially with a very fine cutting edge angle. So abrasive, cutting on abrasive stuff will wear a cutting edge out faster. Cutting on hard surfaces like stainless steel kitchen counters. Irrespective of how hard your knife is, that is going to kill your cutting edge very quickly. The same as cutting boerewors on the braai grill. That's why you never lend your pocket knife to somebody at a braai. They must bring their own pocket knife. Certainly the steel choice. That's a big factor. Steel choice. And I think. Now, when one starts to select steel, you've got to, as the maker, choose the right steel for the job. Because far too often knife makers will just chase hardness and forget about toughness. You can't be using the same steel choice for a hunting knife as you would do for a sword or a dagger or a throwing knife, battle axe. The requirements are different. The one needs hardness, wear resistance. You're going to choose a very high carbon steel for the hardness. You're going to perhaps choose something that likes to make carbides. You know, do you know the Bowler K110, D2, for example? That makes carbides. It's got tungsten in it. Steels with vanadium in it make vanadium carbide. Even chromes, any of the stainless steels, make chrome carbides. Now, anything that combines with carbon makes a carbide, and a carbide is harder than the carbon by itself. So You can think of carbides as a concrete, but with very hard stones in it. Because if a metallurgist looks at steel under a microscope and it contains carbides, it's got these little round, hard clumps. So in the matrix, you've got these little hard nuggets of carbide floating around, perhaps even a softer matrix. So if you think of looking at millipop with stones in it, you know, that's what a steel with carbides might look like under a microscope. You've got the soft stuff with hard lumps in between. So the hard stuff is what resists wear. But at the same time, steel will become blunt by chipping out if it's too hard. Abrasive resistance will increase the harder your steel gets, but to a point where the steel actually crumbles and fractures out. If you look at a cutting edge under a microscope that has been heat treated too hard, the edge doesn't roll or wrinkle or wear away, it actually chips out. So that's another way that a knife will blunt. Heat treatment goes together with steel selection. So you can manipulate your steel through particularly the tempering process. Now, while you guys are here, and some of you are a bit experienced, and others less experienced, the word tempering is often used out of context. Somebody might ask you, did you temper this knife in oil? And you say, no, I didn't temper it in oil. I quenched it in oil. And after hardening, it went into the tempering oven at 180 degrees or 200 degrees, whatever the case might be, to reduce the brittleness and induce toughness and flexibility. The temperature at which you temper it after hardening results in the final hardness of your knife. You harden a knife by quenching it in oil, mostly. There are other exceptions. But the knife will come out of that quench as hard as it can be according to its carbon content, mostly. Okay, so you have overshot the required hardness by a certain amount. By tempering in an oven, and it's kitchen oven temperatures, 200 degrees, thereabouts. It does vary. But through tempering, you now reduce that hardness and you come back to the hardness. You reduce it. You reduce your hardness to the Rockwell hardness that you desire. The scale Rockwell, in particular Rockwell C, is how we measure hardness on knife blades. You do get other scales. You get obviously Rockwell A and B. You get things like Brunel, Vickers, Sharpie. They're all different ways of measuring hardness, impact resistance and toughness and things like that. Some of them can only be done in a laboratory environment. But Rockwell is a very nice way of testing wear resistance or resistance to penetration, actually. Because the way they measure Rockwell is by bearing down on your knife blade with a diamond point. The point of the diamond's got a very specific angle. I don't know what it is. But they will put a load behind that diamond, and that gauge will measure the depth of penetration. Now, if you've got a Damascus blade, you can't really rely on the Rockwell hardness test as a true measurement of hardness, because the Damascus contains multiple layers. Now, depending on which layer you land on, you might be pinpointing the hardness on one layer. It might be a hard layer just on top of a slightly softer layer. So as you put the diamond on, the underlying layer will give a little bit. So measuring Rockwell on Damascus blades is not entirely reliable. If you want to measure hardness on Damascus blades, one will do things like scratch tests, or we're in the workshop, just in a simple workshop environment. I've got a special file that I will use, and I will, not this, but I will use the file against the knife blade and gauge the way it slips and slides off of your knife. And once you've done that a few times, and you've got a knife of known hardness and can sort of almost use that as a gauge or a reference, you will say, okay, that one feels like this, that one feels like that, this is softer than that. It's not really going to be able to give you a number value. All right. Is there any questions regarding what I've just spoken about?
Some knives are sharpened on one side only, and a knife like opening, for example.
Yes, okay, let's talk about that. Yeah, so
what is the advantages, what are the disadvantages of that way?
So a normal knife is made for symmetrical cutting. You will have a grind on both sides, and you will then sharpen this knife on both sides. But now a lot of these tactical fighters, and I know there's some sushi knives, not all of them, but some sushi knives, depending on whether you are left or right-handed, you're going to be sharpening it only on one side, because you'll be cutting only from one side of that fish or whatever you are slicing. So one will now need to take edge angle into account. So if you're sharpening a knife on two sides, you're going to think of your included cutting edge angle and divide that by 2. So if you want an included edge angle of 30 degrees, you now will lay your knife on the oil stone at 15 degrees this side and 15 degrees that side. But now if you've got a knife with a chisel grind and you're sharpening it from one side only, and you want a 30-degree angle, obviously now you lift it up to 30 degrees and you're only sharpening it from one side only. Does that make sense? Any other questions regarding steel, heat treat, blade geometries? We've touched on a bunch of stuff. Okay. I brought here a bunch of various things that are available to you, and not all of them are easily available. But the most common freehand sharpening device is your common carborundum stone. These are a natural mineral, so it's graded. The dust is put through a sieve, and they will make a bonded grit, rough and a smooth side. This might be carborundum. It might be aluminium oxide, it might be silicon carbide. It can be different abrasive mediums. So things that, like your bench grinders, or the grits that you will find on an angle grinder blade, these baby grinders and chop saws and things, that's usually carborundum, the black one is carborundum. But the grey ones are aluminium oxide and silicon carbide. But nonetheless, these things are relatively inexpensive and available through most hardware stores, and you would use this for general purpose sharpening. The mineral itself is very hard, it's very abrasive, so it will remove a lot of material very quickly. So if your knife is very blunt, or the edge is very thick, and you've got a serious, let's say, chip out of the cutting edge, and you need to get down to a fresh new edge without spending the whole Sunday afternoon, you're going to use one of these stones. Okay, so that brings you down to your edge. Once you've got an edge, you would like to perhaps refine that edge with a finer stone. Even the fine side of these stones might not be fine enough for high-end knives. But for most, let's say, kitchen knives and a lot of the commercial knives, you're going to find the carborundum stone more than adequate. Knives for the fishing tackle box and the toolbox and all that, I wouldn't even bother going finer than that. They serve its purpose perfectly. Okay, so that's that one. Now, these here are Arkansas stones. They get their name from the American state of Arkansas, and this is a natural rock. It's mined out of the ground as it is, just like you would mine marble or granite. Okay, they will slice and slab this stuff and glue it to a wooden back, and that's your sharpening stone. But now, because it's a natural rock, it's called novaculite. Depending on which side of the mountain they're mining, you know, the quality control is all over the place. Okay, and the deeper they go, it changes again. So they have a way of grading these Arkansas stones, rough, medium, fine, or soft, medium, hard. Rough, medium, fine, or soft, medium, hard. So the harder, the finer. Now this is what they call black Arkansas. This is super, super smooth. You can take a surgeon's scalpel and just basically strop that over this little black Arkansas stone. It removes like minuscule, next to nothing material. It does more polishing than metal removal. You can get a very, very fine and bright edge on these very fine black Arkansas. On the other hand, you've got this soft or rough Arkansas stone here, and that again will do a similar job to the carborundums. This will remove material relatively quickly. Now, what was I thinking? I lost my train of thought. Anyway, so that's the natural rock. So these you can get. I think KMTS has some. I know Sharp Edge in Sandton City has them. But because it's a rock and somebody had to put it on an aeroplane and fly it here, they tend to be quite expensive. And I think most of that is shipping costs. Because when we've been to the States and we've done some traveling around, and you drive through the area where they mine this stuff, the little town is called Hot Springs, Arkansas. The whole countryside is torn up. Shame, it looks terrible. They've quarried the whole countryside. Every little mountain and kopje is mined out. They've taken these huge blocks out of the earth, taken it to the sharpening stone factory, and with big diamond blades they slice this stuff up. But then obviously every now and then you've got natural fissures and flaws in the rock. Pieces get dropped and they get broken and chipped and cracked, and you get the home industries that will buy up these flawed Arkansas stones, the cracked and broken ones, and you'll find guys, much like in our rural areas where guys stack up on the sides of the road firewood or charcoal. You know what I'm talking about. They will stack on their pavements Arkansas stone, piles of it like this. There's a little sign stuck out on some guy's pavement, and it says, "Sharpening stones, inquire within." You knock on the ring of the doorbell, and some guy comes out in his slippers and he sells you a couple of Arkansas stones for a few dollars. They're actually quite cheap, but unfortunately, locally they are expensive. If you are buying particularly the very high-grade, high-tech, modern, alloyed stainless knife steels, the diamond sharpeners are probably the ones you want to go for. These things don't care how hard the knife is. If you take one of these very, very highly alloyed powder metallurgy steels, I'm not going to mention brand names one over the other, but if you are using them, you'll know what that is. You'll find they are very, very abrasive resistant. And you'll more often than not find these high-end, high-alloyed steels are blunt. And they get a bad reputation because they're not sharp. And the blame is not with the steel, but it's with the guy sharpening it. He doesn't have the abrasive power to bring that thing to a sharp cutting edge. So you'll need to have more than likely a diamond stone to sharpen these very fancy high-end steels. All right, so they also come in fine, medium, and rough. What I have over here, these are Japanese water stones. And these are also natural. They are generally clay. The very, very fine ones, this side here is 6,000 grit. And if you've used some polishing paper, sandpapers, you'll just know how fine a 2,000 is, because that's about as fine. Maybe a 2,500 if you can find it. It's about as far as we know as far as sandpaper is concerned. So 6,000 grit is really, really fine. But if you have a look into this basin now, the stones are quite porous. And you put it in a tub of water, and you don't sharpen on the Japanese water stones until it's fully soaked up the water. It's like a sponge. Right, so this brings us to the things that go with the sharpening stones, and that is either oil or water. If you've got an oil stone, now let's call the carborundum stones oil stones, you're going to use a very light mineral oil. So whether it's these little 3-in-1s or liquid paraffin that you buy in the pharmacy, or you've taken a little bit, as I've done here, this is the Lansky oil bottle, but the oil is long time used up. But I will put maybe just the tiniest bit of engine oil in the bottom there, and then I fill the rest up with paraffin. You want a very light oil, because obviously oil, the job of oil is to reduce friction. And if you put oil on your oil stone and it works too well, there's going to be no grinding action between your knife and the oil stone, and it doesn't sharpen. You need friction, but the purpose of the oil is there to float the debris out of the stone itself, or otherwise the grit gets clogged with knife steel, and then again it doesn't work. So the fluids are there to float out the debris. Now, if you've got an oil stone of any type and you keep it on the windowsill in your kitchen, I would recommend you rather use water. Put water on your stones that are used with food. Okay, that way, once you sharpen the knife, rinse it off under the tap, and you go and cut your food. Otherwise, now you have to go through a whole washing cycle to get the engine oil off your knife. Okay. Obviously, the Japanese water stones are always kept very wet, and I'm going to play with a Japanese stone in just a moment. All right, have I covered all the stone options? I'm not talking about all the assisted sharpeners. Okay, the only one I brought with me now is this one. You know, you've got the Spyderco sharp maker, croc sticks, and Warthogs and Lansky. There's all these assisted sharpeners. Now, what I want to talk about is particularly the freehand sharpening, because the assisted sharpening, in my opinion, it helps you sharpen consistently. It helps you keep a certain cutting edge, but you don't have the freedom to customize that edge the way you want it. The assisted sharpeners are a little bit like the training wheels on a kid's bicycle. Okay, they're good to a point because it helps the kid not fall down. But eventually they can ride a bicycle and they want to start doing donuts. And they can't do donuts with side wheels on. So you must take the side wheels off, and then you've got freedom to do what you like. And that's when you start getting creative and going ramping and all that kind of stuff. So you get the analogy, what I'm talking about. So with the freehand sharpening, you can vary the angle as you wish. All right, so I'd like to just briefly talk about did we just slosh this? It doesn't have a leak, hey?
Sloshed it.
Okay, yeah, maybe when the table moved. All right, so determining bluntness now is the first thing. You can be sharpening and sharpening your knife, and how do you determine when it's eventually sharp? You know, eventually you've ground the whole knife away, but when's it time to stop? You know, eventually too much of a good thing, it becomes a bad thing. So the most common way, I guess, is to take a piece of paper. All right? You want to be able to do that. A big old paddenslachter like that doesn't need to be blunt. It must be shaving sharp. Little hunting knife, utility knives. Let's see, I just grabbed a bunch of knives at home. You know, you want knives that are sharp, because eventually, as a knife user, you get so used to having a sharp knife, or so treated by having a sharp knife. It's a lacquer feeling. The moment the knife is just a little bit blunt, you can't deal with that. You have to go sharpen it again. And it should take literally a few seconds, swipe, 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 and strop. I'm going to talk about that. And the knife is back to good as gold again. All right, so we like to have knives that are always really sharp. The other way is obviously to take the knife against arm hairs, and if the arm hairs jump off in fright before the knife touches, then you know your knife is really sharp. Sorry, it's an old joke. Now, the guys who've been on course with me probably heard it, hey? Brad?
Yeah.
All right, so let's find another way of testing knife sharpness. And the way I like, because eventually a knife maker runs out of armies and then we can't reach our backs. But the way I like is to just put the knife against your nail at a slight angle like that and put a little bit of pressure as if to carve into your thumbnail. And if the knife is sharp, it will bite. It bites in there. And you do that all down the length of the knife, right to the tip, and right here to the choil. That's the choil here. Okay? Must bite. Now, if the knife is blunt, now let's take this knife, and now somebody has cut on the bri grid with my knife. Okay, that's killed that cutting edge. Now you do this. Look at that. It skids off. Okay, you saw it shave a moment ago. It cannot. Okay? It tears the paper if I push down hard, but it's not shaving. Okay, so we know the knife is blunt. So we now need to determine just how blunt is this thing. Which stone are we going to start with? Because you're going to start with the roughest one and eventually work your way through to the fine stuff. Now, you can, in good light, look straight down on your cutting edge and you will see a flat spot. Now, I mean, I would never have done this a little while ago. Okay, that would have been just stupid. But I can see right here on the belly of this knife there where I've cut onto the oil stone, there's a bright reflective flat spot. Now, it may have worn it away. It may have folded the steel over. So, depending on what your edge angle was, different things may have happened. Now, I can actually maybe hook a little bit of that cutting edge. So we can go to a carborundum stone. Let's bring this back to fresh real quick. I'm going to put this rag down that I don't... I'll use the cloth. I don't want to get oil on the tablecloth. Okay, so it's very thin. I mean, this is basically paraffin that's been dirtied with engine oil. That's how little.
Something like Q20, for instance.
Yeah, it'll work, but any of the aerosols by volume are very expensive.
Okay, but
yes, it will work. So any of the light oil. So you will now determine your edge angle, and my sharpening method is... No, that's not going to work.
Are you going to do the paper? The double block? You just
Flick it like that.
Now, all your sharpeners got flat edges. The butchers had round files and that.
Yeah, that's a butch.
Very quickly to sharpen.
Okay, that's a good question because I've got lots to say about a butcher's steel. Your butcher's knives, the chef knives, are very often a lot softer than our hunting knives. Those that I've measured will be in the region of maybe 52 up to maybe 55 Rockwell. They're a lot softer than our hunting knives. And the butcher's steel, I don't have one here, but the purpose of that is to maintain an edge. What it's doing, it's pushing that steel that may have folded over back up into alignment. It keeps the burr upright. Because when a blade is sharpened and the edges come together, eventually the steel is so thin, it will fold one way or the other. That's the burr. A butcher's steel will maintain the burr upright. Now, if you've ever stood in the queue at a carvery restaurant, you know these buffets where you walk down the queue and the guy asks you, do you want chicken or beef? And he carves the roast, the mutton or something, he comes up against the bone. Before the next guy comes, he must touch the knife up again. The burr has bent over. So that's what a butcher's steel does. The steel rod has got little ribs on it, so it's not really an abrasive. It's just a hard burnishing tool of sorts that keeps the edge sharp. If the guy who was cutting the meat was to take the time and actually sharpen it on an oil stone and strop the burr off, that there's no more burr, he would find he might do the whole evening without having to sharpen the knife again. Because it's the burr that is the problem when we use a knife, that it goes blunt just like that. Because if you don't wipe the burr off, the first time you cut up against abrasive or hard, the burr bends over. Now you've got a knife with a rounded cutting edge. Does that make sense? So it's not so much the knife that's gone blunt, but it's just the burr that's bent over. If you were to simply strop that knife against the leather, what I've got in my workshop is just a plank of wood that I hold in the vise, and you are wiping that blade backwards and forwards like that until that very, very thin burr has been flexed backwards and forwards a couple of times, and eventually it cracks off. Sometimes on soft steel, like cheap kitchen knives that you buy, that burr comes off as a curly shaving. It almost looks like a drill shaving or a lathe turning. It comes off in one long curly piece, the soft steels. The hard steels will break off in tiny little chips.
The barber knows more than the butcher.
Yeah, the barber strops have got very often what they call rouge. They will put a silicon carbide or aluminium oxide dust. Basically what's in this stone here, they put a powder on that leather. And when they do that, it's still removing the smallest amount of steel, but at the same time polishing and stropping the edge. And because of the slack leather, you're getting a convex cutting edge, which is what I'm trying to achieve on these forged blades of mine.
That knife will last forever.
Yeah, so just the slack of the leather puts the correct geometry on the cutting edge. Right, let's see if this sticks. What I've done now is I've just dampened the cloth to stop the stone sliding around on the kitchen counter. You can put, have I got to add some of these? There's a little bit of rubber there. It can help, but simply wetting your dishcloth and will stop the stone slipping and sliding. All right, so I've chosen an angle, and I don't know what it is, but something like that. So if you can visualize that from where you are, that's about right. There's something that I call the rule of thumb angle. You know what a rule of thumb is? It's like a plus minus more or less kind of thing. Now, if you take your knife, now it works best actually with smaller knives. You're going to sharpen this knife against the oil stone. Your thumb is on the top there. If you lay your cutting edge against the stone and your thumb just lightly touches the oil stone, your edge angle will be more or less in the right place. If you lift your angle up higher, your thumb lifts off the stone, and now that's too high. That's maybe a 45-degree angle. Now you do 45 this side and 45 degrees that side, your included angle is 90 degrees. That's like just useless. Super durable, but not very sharp. It's going to stay blunt for very long. Okay, so that's the rule of thumb edge angle. Obviously, when you swap sides, now you can't put your thumb the other way, but it gives you an idea of what it looks like. All right, so let's actually do this now for a bit. Right, so I'm power stroking into the stone, right, starting at the tip and working my way all the way around to the choil. You don't need to do this. It works, but it's slow, and it's for people that get paid by the hour. Okay, you want to get this job done because the family is waiting at the dinner table for you to carve that little bit of roast beef, eh? You'll swap sides. Now you're going to shave the top layer of the stone off towards you. The power stroke is towards you now, like this. You see, I'm keeping the relative angle to the stone consistent all the way around. You see how I'm following it here like that? I'm not doing this. That would be wrong, because now my tip geometry is all wrong. Okay, unless you wanted a durable tip and a razor sharp section here, you can do that.
Now the way you're doing it now, if you use it the last speed, you do it the other way around. You clip the knife together and then you move the little stone in the corner. Now I used to sharpen my father's sense from Europe with a stone because it's a big blade.
So for example, now if you've got an axe, you might hold the axe and take this like this.
It's the same.
Yeah, it's the same. It will work. It's relative movement between one surface and the other. All right, now, have we done enough with that first side? Maybe not. Yeah, things are coming right. Okay, let's go a little bit more. I want to bring this knife back to shaving again.
Given your backstroke, basically, is that just
It's just a recycle.
you don't put pressure on the back?
There's pressure, and I'm sure there's... I mean, if there's a really blunt spot, no, there would be nothing wrong. Okay, that bright, shiny spot has sort of started to disappear. I know I'm doing something right. But there would be nothing wrong with doing this. You're grinding that blade, removing material, backwards and forwards. There's nothing wrong with it. Get the job done. Right, now, if the edges come together, you're going to get a tiny little burr. Now, depending on which side I'd have sharpened last, the burr turns away from the stone. All right, so if I sharpen this way, right, for those at the back, if I sharpen this way, the burr has turned up that way. If I test against my nail, the burr is acting like the tip of a water ski. It causes that knife to skid over the top of my nail. And you think you're still blunt, and you sharpen some more, and you go again, and it's still blunt. But actually, if you had just finished off in this direction, right, now the burr is this way, turn the knife around, the burr is now hooking down. Look. You see that? It's a common mistake. Okay, testing for the sharpness, following sharpening, taking the direction of the burr into account. Okay, so now I know this edge has come together. So now I can flip this over. The other side of this carborundum stone is slightly finer. The big work is now done. This really doesn't take long now. All we are doing now is polishing and refining the edge. The clip on this bow is also pretty sharp, so I've got to watch out. The angle is still the same. So now we're starting to polish and refine. I mean, that has now come together. All right, now we can go through all these stones right to the Japanese water stone at 6,000 grit. And we will probably do that just for the fun of it. But one must also understand that depending on how fine your polish is on the cutting edge is also going to affect how it cuts. Now, there's two different ways you can cut something. You can shave it like a razor blade or a plane when you're planing wood, a houtskaaf. Okay? So it's a shaving cut. It's a push cut like this. Okay? There's a slice cut, which works differently. So if you've got a shaving cut happening, let's say that's the purpose of that knife. It's a wood carving chisel. You're going to want to polish the edge. The brighter the polish, the better. Okay? But if you're wanting to slice cut as the knife's primary function, and particularly slice cutting anything with abrasive fiber, so if this is a rope cutter, or it's a beef slicer, okay, roast beef, it's fibrous. So you want to leave that cutting edge just a little bit ragged, okay? It mustn't be polished. Okay? Now, when I say polished, I'm talking about a fine stone. I don't like buffing cutting edges, because as you put this blade over the electric buffer, the fluff of the buff goes like this, and as it flips off the edge of the knife, it actually rolls the edge over. So you're getting a very brightly polished edge that can shave, but what you've actually done is done this right on the microscopic cutting edge, and you've made the knife perhaps more durable, but it's less sharp. So you can get a polished edge with a true angle by just going to a very fine stone. And that's my preferred method, a fine stone, no buffed machines. Okay. Besides that, taking a knife blade that is now scary sharp to an electric buffer is probably the most dangerous thing you're going to do in your workshop. And unfortunately, it's the last thing you're going to be doing. You've already phoned the customer to say the knife is finished, put the money in the account, come and collect it. Now you sharpen it. Putting it on the electric buffer is not the time to have the knife get chucked on the floor and tangled up in the machine, bouncing off the ceilings. Okay, it can be very, very dangerous. About 2 years ago, we saw it on Facebook. One of the American knife makers had a knife get thrown off the buffer straight into his chest. He died on the spot with the buffing machine still running. Threw it straight into his chest. So the buffer can be very, very dangerous. That spinning wheel, it's all soft and fluffy and cuddly. But put it at speed. Those little hairs and fibers are just waiting to grab over a sharp edge or point or something. They hook on sharp edges. I've had one chop into my knuckle, this knuckle. Big old scar there. A big flap of skin coming out. If it had just been a bit different, I might have chopped the finger off. Alright, so now we've done the fine stone there. Let's now go to, this here is a medium Arkansas stone. It's going to be finer than the carborundum. Now what I've been doing up to now could easily have been done on the diamond stones, rough, medium, smooth. Can you hear the sound is even different? What is the time, please?
20 past 2.
20 past. All right, now one can consider the sort of setting up of your angles and bringing it to an edge as phase 1. Once you know that your edges are together, now you enter into phase 2, which is just sort of the polishing and the stropping phase. So I might even start easing up on the pressure now. Start swapping sides a little bit more regularly. And what's going to indirectly be happening is the burr is flexing from one side to the other. And you will know if you have taken a piece of blow drop. You flex it backwards and forwards a whole bunch of times. Eventually it fatigues and it cracks. Okay, so this is kind of what I'm imagining is happening on the oil stone. You're sharpening, alternating sides, swapping sides regularly, and that burr is bending one way and the other, and eventually it also becomes weaker and weaker, and maybe parts of it are cracking off on the Arkansas stone even as we speak. There is a thought amongst some of us who make combat fighting knives about the absolute tip geometry of these fighting knives. Now, this is sort of a combat fighter. It's not quite big enough, and there's a nice one on my table. But one can sharpen this edge up to the point, leaving the point as a needle point. Okay. The other option, which is my choice, is to actually sharpen that point around the point. That the point is actually curved. Okay? If you look at this knife, it looks like it's got a point, but it's actually a round. Okay, and the only reason for that is it makes that tip geometry stronger. Okay? A very fine point can easily get chipped or break or bend over or something like that. By sharpening it around the point, you've just increased the strength, the robustness of that tiny, tiny pinprick on the end. And the way you sharpen the tips on those sort of knives is like this. So you've got your edge angle there, you lift it up to that. This angle now is your edge angle, and you go around the tip this way. You can do it this way too. But you see what I'm doing here? I'm sharpening the tip around the tip. And ultimately, once we get to the final stone, I should be able to cut backwards with the tip. Okay. Right, by now we've got these water stones that are nicely saturated. One doesn't want any oil on those stones. They only want water. Okay, so wipe it off with the knife.
We use a paper cutting test now. It will cut the paper at this stage.
It may not, because, let's try, because it may still have a burr. That's doing pretty well compared to the way it was before. Eh? Alright, so let's just look at our grit sizes here. It's difficult to say what that last Arkansas stone grit size was. So I've got a 500, a 1000, a 1200 and a 6000. So let's go real quick to 1000 and compare it to what we've just done with that Arkansas stone.
To go back to 5 minutes now. To go back 5 minutes, temperature is never a factor in sharpening.
Not with hand stop sharpening. No, you're talking about friction.
Yeah.
Never an issue with hand sharpening. And that's probably one of the big benefits. You know, putting the edge against any form of grinder, whether it's the belt grinder or whatever, your huge risk is the friction of the belt. And if you're going to go fine edge, you know, you sharpen that with a 400 grit. I mean, here we're going much finer than that. So a 400 grit is not very famous for its grinding ability. It's a polishing belt. So the friction skyrockets. And you're sharpening on the thinnest part of your knife. And believe me, that piece of steel can get very hot very quickly. And we spoke about tempering earlier. You're tempering at 180 or 200 degrees. That's the temperature that cookies come out of the oven. Okay? As you are sharpening this knife and you're dipping it in the water, chop, you'll find that the water is steaming and boiling on the cutting edge. You've reached 100 degrees already. You're halfway to burning your cutting edge. It's very dangerous, you know, risky. You know, you can very easily exceed your tempering temperature, and you don't have to go very much beyond for it to start having a profound effect on the Rockwell hardness. And now, right where it counts, your steel is softer. You thought you tempered it and you've done everything according to the steel manufacturer's specs, but you've destroyed your cutting edge hardness simply by heating it by friction. Right, so let's now keep this water stone damp. So you're always going to keep that wet, and that's just water. It says dog spray. And that's little perfumed water that my wife makes to squirt on the dirty dog's beds. Makes their beds smell fresh. Alright, so here we can very lightly, you might even go in circles, but we're kind of polishing and grinding, but we are not stock removing in the true sense of the word. We're not grinding huge amounts of material away. This is well into phase 2 of sort of refining and polishing the cutting edge. Now this 1000 grit feels very nice compared to the Arkansas stone. Alright, let's swap sides. No, that's 6000. There's the other one. 1200. A little bit finer. Let's just feel it. That's this white one. Now, this little stone here, this is just a regular pocket stone, these Arkansas stones. But one might find that the pocket stone can be used to dress and refine, to dress this water stone very nicely. It makes the surface nice and flat. It freshens it up. It prevents, it removes all the clog that's happened in that there. Now, the finer you go, you'll find that these stones become very, very soft, the Japanese water stones. So by pushing the knife into them, you actually start carving the stone up. If I was to gouge the stone with a knife point, it comes off like soapstone. It's very soft. So you start changing, depending on how soft the stone is, into these drag cuts. You're dragging the knife now over the stone. If I carve into the stone, it starts to eat the stone up too quickly. And all this grey that's now left on here, so it's doing something. And by dragging it like this, we're already doing some form of stropping. That burr is getting weaker and weaker. The cutting edge is becoming more and more polished. You see that and that. See those two stripes? That's steel being left behind. So it's doing something. Okay, so back to this one, last one, 6,000. But this is more than you would ever consider normal. On the Japanese samurai swords, that nation of people are so particular, and they will take paper folding and turn it into an art form. Macrame, weaving pieces of string, with their samurai swords, whether it be sharpening or making the sword fittings or whatever, these guys were passionate, and there was nothing half measures about what they did. You must agree with me.
Kevin, in the movie The Bodyguard, there's a scene where they drop a silk scarf over a blade.
Yeah.
And it cuts the scarf in half. Is that anywhere close to realistic or not?
I think just the weight of a silk scarf is too light. I think that's a bit fantasy. There's like the King Arthur legend, where a similar thing, a silk scarf is floating down the river, and he puts the sword blade in the river, and as it touches the blade, the drift of the current separates the scarf in two. I think that's also a bit fantasy. But I mean, if you guys want to have some fun, go on the internet and look at and do a Google search for blade sports. It's cutting competitions where these guys chop and slice against the clock, and how many you can do, and all of this stuff. And you see what knives can do when wielded at speed and power. It's crazy.
The same as a few years back that they had that cutting competition outside.
Yes, it's good fun. Yeah, it's good fun. Yeah, so this is now 6,000 grit. Just a few wipes here. Right. Now the stropping. If you've gone really fine, maybe even it started to do the work of stropping. But obviously stropping is against the leather like this, not into the leather. You're flexing that burr backwards and forwards, and you might even increase that angle against the leather just a little bit, that the stropping action is acting right on that microscopic little burr that's on the cutting edge.
What compound do you use on the leather?
This is just pure leather.
Pure leather.
It looks all bright and shiny. It's just over time it picks up oil, and it's not. Yeah, it's a good question. It's not so much about putting any fancy abrasive compound on the leather as the action flexing the burr backwards and forwards. I could take my belt off now and strop just as effectively, or against the sole of my boot. If I was to do this, it will do the same. Against a piece of soft campfire wood. It's less about what you're stropping on, but more about the action. action.
That's always leather.
No, it's just a rubber plastic.
What about if you use just a piece of wood, and also in this case, there's the same effect on a piece of rendering?
Yeah, a soft piece of wood. It flexes the burr backwards and forwards, and eventually the burr will break off, because it's when you start using the knife and you haven't taken the burr away that the burr bends over, and now it makes you think the knife has got blunt, but it's not the knife that's blunt, it's you who didn't strop it.
So that guy's using glass, you can use glass for that as well.
The glass will be doing the work of the stones. You might still want to strop it. Let's see what we got here now. And it must do that right to the tip.
Mr. Harvey, it will cut.
It will heal. I don't know. So if somebody's got a lucky hairy arm, you're welcome to shave your arm with that. But I believe it will do it. So yeah, it's got a very bright cutting edge. It's fine. It will slice very effectively. But maybe 6,000 grit was over the top. It's not necessary to even. You don't have to go to the ends of the earth to find Japanese waterstones. They are just for those of us who are a little bit pedantic.
Where do we buy this stuff in our country?
The carborundum stones, you're going to find them at most hardware stores. The diamond stones, I know Hardware Center in Hanstredo. What's it now? Libongwe. Hardware Center. You can look them up. They've got lots of diamond sharpeners. And then Sharpshooter in Sandton City. KMTS, I think, will have some sharpeners as well. Are there any other questions?
Just in terms of the fighting knife, you mentioned that you might want some bite in the edge.
Yeah.
What grit would you go up to if you wanted to?
Yeah, like I say, it's difficult to know what grit this is, but a medium Arkansas is beautiful. And a working field knife, a medium Arkansas is lovely. And for my carbon steel knives, and again, it's a philosophy and a thought process, because my knife making is sort of historical. So everything I do is old-fashioned. I'm going to sharpen it on an on a carborundum, on an Arkansas stone, because that's the way it would have been done over the ages. Diamond stone is brilliant, but it goes against the grain when you've been making knives old-fashioned. Just like I'm putting Danish oil, tongue oil, London oil, all these kind of wood finishes that they used on expensive shotguns and stuff 100 years ago. That's the kind of wood finish I'm putting on my woods. I don't want polyurethane on my wood. Yeah, chachi. But it's a beautiful thing. It shines. I mean, it makes it waterproof. There's nothing wrong with polyurethane, but it doesn't suit my philosophy. So the same is with the stones. Diamond, Arkansas stone, you've got to kind of pick and choose.
There's no rules.
Do I say that?
And then, in terms of holding the edge after you've sharpened, do you use ceramic rods?
Thanks, guys. Thank you so much. If it goes step by step, finer and finer, and that's what you want, yeah, you can use it. You just got to find where does that ceramic roughness fit into the sequence of stones that you're using. So you might use a carborundum and finish up on the ceramic. 2 steps, something like that. Just incidentally, some of the other goodies that I've brought along here will be for sharpening things like serrated edges. We never really touched on that, but you will literally sharpen, like the Spyderco knives, you're going to literally sharpen each tooth individually with these tapered diamond-coated rods. You're going to sharpen the serrated blades from one side only until it pushes a burr over on the other side. You're going to maybe at a very, very flat angle on the reverse side just sort of hone the burr away. Strop it. You're going to work off the corner of your leather here, stropping one tooth at a time. It does take a little bit of time You're going to sharpen each tooth as if it were a blade of its own. And you can get them scary sharp.
For interest's sake, the Boca Batman knives that you developed, how would you sharpen those? Also again with the taper?
Yeah, so what you're talking about is that.
Correct.
Okay, so sharpening off the corner like that. See what I'm doing? Like that. And that way. You're working off the corner and it just undulates and scallops. So yeah, you can't sharpen a funky knife like this just on the flat of the stone. It's not possible. Anything else?
On your grit belts, before you sharpen with the stones, to what grit do you go? 400, 600?
Because I'm working with carbon steels and I've got flat grinds with convex edges, I'm doing my blade geometry already at 180 grit before I even hand polish. So I'm hand polishing on a blade that's already sharp while I'm polishing the blade to a shine. I will shave paper before the handle is even on. It kind of works, it's a bit odd, but it goes with the convex cutting edge method of my blade geometry. But for stock removed knife, you can go 220. 220 makes a nice cutting edge. It might be a little on the rough side. 320 is better. 400, you're running the risk of burning. I like hand sharpening. But if you want to just set up the cutting edge, you've left your cutting edge thick. It hasn't got a cutting edge. I will set up the edge by bringing them together maybe with a 180 and then go over to a stone. Does that answer the question?
Kevin, I know it's strictly about sharpening, but could you talk a little bit about different carbon steels and what you feel is the best to get the best edge? Do you think that, for example, like 5160 or 1095, like a little bit about the advantages of the different carbons or the best edge?
Yeah, so you've got very interesting metallurgy that happens with regards to the carbon content. And at 0.77% carbon, I mean, one can go into a whole lecture just on that. To the lower end of 7.7, you've got what they call hypoeutectoid steels. And after 0.77, right up to high carbon tool steels, you've got hypereutectoid steels. And it's all to do with when you heat treat the blade and how the carbon and the ions bond together, because that's what steel is, carbon and iron. If you've got an excess of carbon, you've got these free carbons floating around with nothing to do. They're looking for a buddy. And that's when you start adding other alloys, like the vanadiums, chromes, and all of that, and you'll end up getting these carbides forming. It gives those free-floating carbons that are left over a buddy to join in with. Whereas if you have less than 0.77% carbon, I'm talking about simple carbon steels now, there will always be enough iron to join up with the carbon, and you're never going to have leftover carbons. It's, I'll make the analogy like if you've got a hypereutectoid steel, so that's the high carbon steels with very low alloy contents, no other fancy vanadiums and so forth. It's like going to the matric dance, but there's too many guys and not enough girls. You'll end up with guys that have no date. And if they don't have a date, they're not inside the hall dancing, they're outside drinking dop and smoking. Okay, get up to nonsense. So you have to give them a friend. You see. But I mean, there's a saying amongst the bladesmiths, we're talking about carbon steels now, Stephen. A very popular and common bladesmith steel is 5160. And there's a saying that says, if in doubt which steel to use 5160. It tends to have the reputation of like a beginner steel, but it's not so much because of that, but it's user-friendly. Okay? You can make anything from a sword that can bend in a half circle, because 5160 is a spring steel. It's designed to flex. very
So there's
flexible.
a high level of ductility.
Yeah. But on the other hand, when that 5160 is quenched and comes out of the oil, it exceeds your required hardness for a hunting knife by about 2 or 3 rockwool. It comes out of the oil harder than you want anyway. So when you temper your steel, by either tempering it back just a little bit or a great deal, you can land up with a whole spectrum of hardnesses, right from hunting knife hard to sword flexibility and anything in between. 5160 is a nice one, but you know, a lot of the carbon steels are read about in the American magazines, 1084 and 15N20, and some of them are not so easy to get hold of. So 5160 for a bladesmith is a relatively easily obtainable spring steel. But not all spring steels, just because it came from a leaf spring doesn't make it 5160. You get EN45, which is one that I don't like. Its carbon content is 0.45. That's too low. You don't get the... For a sword, yes, maybe it's okay, but not for hunting knife. Silver steel is a very nice one. It unfortunately only comes in round bar. So you've got to hammer that stuff down into flats first. Silver steel, for those of you who know what it is, will make a very nice clay Japanese style Hamon line, heat treat line. Silver steel.
Is silver steel similar to W2?
Yes, carbon steel wise and its simplicity. Silver steel is not a highly alloyed steel. You know, it's got very low trace elements of other stuff, but it's 1.2, I think, if I'm remembering correctly,
1.2.
carbon.
And 52100 it has this reputation of being this almost like super carbon steel. Is it?
Yeah, Ed Fowler's done a very good marketing project on 52100. But yeah, I mean, to use bearing steel and heat treat it properly, it does make a fantastic blade. It's of similar carbon content to silver steel. Silver steel is probably a bit higher. But 52100, if you thermal cycle it properly, I don't know, how many of you are bladesmiths? You are forging. You know, you can normalize 52100 and get a very, very fine grain, which makes, the finer the grain structure, the better its edge holding again. So you can take two blades from the same steel, and you've normalized one properly, and you have not normalized the other one at all, and you're going to get two very, very different performances out of the same steel. So steel performance is very much dependent on the guy building the knife.
Kevin, with apology to the audience, they need you upstairs.
Oh, is it? All right, that's fine. I know the show's coming to an end, and there's lots to do. But anyway, I think we've covered everything that is most important. Thanks for being here.
Thanks a lot.